Good day, everyone. Let's have a look at this questionnaire matrix. If n is given as this matrix, we have to find the inverse of n. n raised to the power of minus 1 is inverse of n. A solution. The inverse of m we can write as the adjoint or the adjugate of m divided by the determinant of matrix m itself. So it's advisable we find the determinant first, because if we find out eventually that this matrix is a singular matrix, then we can say its inverse is not defined. So let's find the determinant. So the determinant, as we know, is the product of the element along the leading diagonal minus the product of the element along the minor diagonal. So this gives us 0, negative 5 times 0 is 0, minus this should give us 21. So the final result for our determinant should be, minus 3 times 7 minus 21, and the final answer should be positive 21. So we know the determinant. That means since it's not 0, this is not a singular matrix. Now to find the adjoint of a matrix, especially if it is 2 by 2, can just summarize it in these few steps. Exchange the elements along the leading diagonal. So we have 0 and minus 5. So we exchange the position. Then the element along the minor diagonal, we multiply each of them with minus. So this becomes minus 7, and of course this multiplied by minus gives plus 3. So we can say that the inverse of matrix M, which we say is the adjoint, which is this matrix, 0 minus 7, then 3, and negative 5, all divided by the determinant, which is 21. So we can express this as 1 over 21 multiplied by this matrix, which is 0, 7, minus 7, then 3 and minus 5. So we can leave the result this way, or many times you could be asked to simplify further by doing the scalar multiplication, the scalar product of these two matrices. So we can eventually say the inverse of matrix M will now be this multiplied by this gives 0. This multiplied by this will give us minus 7 in 21 is 3. 1 divided by 3. Then this multiplied by this will give us 1 divided by 7. And lastly, we should have minus 5 divided by 21. So this is the final result. I hope you find this useful. See you on the next one.